you guys all for joining today. We're talking about modern world of AI and fleet. So we'll look through just a little bit overall. What is AI? I'm sure no one in this room's ever heard of it. I think the only word used more now is tariffs. So we're going to focus on AI today. We'll talk a little about just AI in general, what it is, kind of how businesses are using it as a whole, but then more importantly, how fleets are using it. I work for a company called Pitstop AI. We're an AI-enabled tools company focusing originally on predictive maintenance. So we've been around about a decade now, partnering with companies like Assetwork, all the telematics companies, really anything that has to do with data and fleet. Originally, we got started working directly with the OEMs, from truck manufacturers, Ford, Toyota, Mazda, a whole bunch of companies to be able to tell them what they should expect for their vehicles, how they should be maintained, what's possible using AI and machine learning, and really tell them how they could produce better vehicles so that their end customers would actually have better information other than OEM guys that are wrong all the time. To really be able to do that, we thought we were going to come change the world. Well, what you learn when you work with OEMs and giant companies is they really don't want to hear what's wrong. They don't want to hear that their vehicles are going to break down. They don't want to hear that they're going to have recalls. It's going to cost them a lot of money. So we did that for about 4 years, working with all of them. And it didn't really get very far. But what it did give us is a giant data set. So we now have hundreds of thousands of vehicles data back then to be able to understand what they're doing, what's going on, be able to create algorithms around them. But really we wanted to come and be able to help the end users. So about 6 years ago, we pivoted, working directly with fleets, people that have more than one vehicle to deal with, that have lots and lots of vehicles to deal with, and knowing the data would grow even more to be able to drive it. So when you're working with AI, you want a lot of data. So today we'll go through kind of how we got started with predictive maintenance, which is probably the most popular in the AI space within fleet. What else is live that we've been working on, and kind of what the future looks like, what the roadmap looks like with that. So we'll start with the top. What is AI? So this is a top 50 search term on Google every single month for a long time now. Because everybody hears about it, gets talked about it. If you've been to conferences like this or some of the larger ones, every single booth says AI. I was at one of the telematics conferences this year and actually went up and saw a booth that had iPad holders for trucks. And so they're AI-enabled iPad holders. And I asked them what that meant. That's about how I felt afterwards. They couldn't tell me what that meant, but they had it up on their board to make sure that everybody knew that they were brand new in the AI space. So what people think AI is Terminator, that machines are going to take over, the cars are going to drive themselves, all the jobs are going to go away. But really it's just a smarter way of doing things. When we talk about AI, we talk about large amounts of data, and there may not be, outside of a few industries, more data than what's coming in from vehicles because they're constantly on the road, they're constantly moving, they're constantly changing, there's so many subsystems, sensors within the vehicles, more AI being put into the vehicles themselves, and it's too much data to be able to handle. I'm assuming most people in the room have some sort of telematics or GPS of some sort. Does anyone feel like they're getting 100% ROI on that data? Anybody getting 50%? That's pretty standard. Most people we talk to and ask that question, they say, well, we might be using 10% of it. We'd have to hire a whole team to be able to go through the data. And that's where AI really comes in. How do we make sense of the data using machines to be able to now visualize that, be able to use it, be able to understand it? You know, what are we really doing with all that data? So if you think back 10, 15 years to the early 21st century, it was all about getting data. It was the original information age. We need a lot of data. And then we got all this data. We didn't know what to do with it. The goal was, we're gonna make data-driven decisions. What that meant was large teams of analysts, really expensive employees, to then give you spreadsheets and go, all right, now maybe we'll make some sense of it. With AI, this happens in real time now. As a company, we're looking at over 50 billion data points a month from just the fleets we work with, of both the OEM data and our live fleets of about 1 million vehicles on the road worldwide. So we're able to now use that data and really make sense of it to be able to now provide that information out to fleets and be able to get that decision making, get to the translation layer, get to the report or the dashboard that actually can tell you this is what we want to do with it. And it's not just fleet, obviously, it's all over the place. Forbes did a big study at the end of last year. I think it came out in October, and they surveyed CEOs and top-level executives at thousands of companies and came back 83% said AI was going to be a #1 priority for them in 2025. And I thought that number was really big. But then the more people I talk to in the fleet industry and other businesses, it actually might be low. It feels like just about everybody, unless they truly think AI is Terminator, they are going to try to put AI in there because getting to that data-driven decision point, being able to do things better. When you think of the business landscape as a whole, people are using supply chain, marketing, data analysis, inventory, customer support, really all over the place. But the common theme is optimization. How can we do things better, less time, less people, put people in jobs where they can actually excel instead of having to go try to figure something out where they're spending all day in spreadsheets and really not getting to where we want to be. And being able to ingest that data is a huge problem, especially in the fleet industry. So we've solved that as well. We're going to talk a little bit about that as well. So specifically in fleet, we're going to talk about what are the top fleets doing, what are we seeing out there, and then truly what's possible. So part of what I'll talk about today is what we're seeing on a day-to-day that fleets are using all the time. Part of it will be kind of what's starting to become live, and then what's on a roadmap. And if you think about how fast the data moves, the AI companies move even faster. So for instance, us as a company, we've had 21 product releases in the last 90 days. Because the data grows, we're getting more and more information, we're able to do more with it. So things that we thought, oh, that's a 5-year plan becomes a 5-month plan. These are the same types of things that we're seeing with our fleets, where they say, I really wish I could do this, it's just too hard, there's too much data, don't have the people, don't have the manpower. Things move so fast within this world, we're able to do more and more. So similar to the 83% on the last slide, talking about global AI automotive market, they believe it's going to surpass $74.5 billion by 2030. This number, I think, is really low as well. Compared to what's possible, what we've seen just within the last few years of the growth within AI, companies are going to be shifting large budgets towards this, being able to do 10x what they were doing before, if not more. And with the vehicles getting more AI in them, it just creates more visualization within all the data, everything that's going on. So if you think about today, we're getting some information from the vehicle, but it's usually through a third party, it's through a telematics company, through an asset management tool, something like that where we have to be the middleman to be able to bring that in. As the vehicles get more and more data to them, we're going to be able to understand even more and do even more. So currently today, we're looking at things like, for maintenance specifically, telematics data around trouble codes. We're looking at some systems and the sensors within the vehicles. Those sensors are just going through the roof. We get more and more all the time in electrical and diesel exhaust, really just about everything. And the big players within the space understand they're going to need to do more of that to stay within it. So as the OEMs spend more in AI, it's going to provide you with a lot more data to be able to do things with. So really what's going on today with an AI? It's a lot. Here's a few examples. Route optimization and dispatching is becoming very big. Predictive maintenance is huge and one of our specialties. Driver monitoring and safety, which actually comes in hand with the maintenance a lot of time. All the analysis of telematics data and other sensor data, and then regulatory compliance. So really understanding how vehicles are being used. And the great thing is at this time, with the telematics data, we're truly looking at everything. From weather, from terrain, what part of the world you're driving in, how often are the vehicles driving and stopping in idle time, looking at how much gas they're being used. Really the sky's the limit. And being able to provide that data back to the customers in a way that's actually being used, unlike the telematics data, just raw, as we talked about before, there's a lot of noise. And being able to really understand everything that's going on, even in a small fleet, is more than typically even one team can handle. So everyone's looking for those benefits. Everyone's looking to be able to do more. We're going to focus a lot, like I said, on maintenance within this specifically because it's such a big topic and it's growing so fast. But also the analysis piece of it. And really what we're looking for is how can we be more efficient? What's possible? And typically when people think of predictive maintenance, they think, okay, you're going to tell me when my vehicles are going to break down. And that's true, but that was true 3-4 years ago. Today it's so much more than that. It's how do we stop it from ever getting to the point of breaking down? How do we do more with less? How do we bundle services in together? How do we make sure that vehicles aren't coming back over and over and over again? How do we understand which technicians or which shops that we use, both externally and internally, are the cause of the problem? And because we're bringing all this in, we can now understand from a maintenance perspective, what's really going on within our shops. You know, is one technician better than the other? We have a training opportunity where we need to get people up to speed. We need more education. And these are the pieces of AI that we really don't think about when it comes to maintenance. Because we can now use the data in so many different ways, we're not just doing analysis on the vehicle, but we're doing analysis on everyone that touches the vehicle. We can now understand that the mom and pop shop down on the corner is actually much more efficient than the big dealership that we use for things. So being able to take a look at everything all in one, and then bringing it back to the asset of saying, how do we use AI, how do we use machine learning to understand, not only within our fleet, which are the best vehicles, but against their peers across the world that are similar, how are we doing? So now we can understand, you know, do we have the best maintenance on our F-150s versus the guy across the country with his F-150s? Being able to understand, how do our vans who are going on similar trips, stop and go, delivery, how are those working against other ones in similar fashion? And this opens up the world even more for us now, because when we talk about data-driven decision making, there's a much bigger picture. So think about you're at the end of the year and we're trying to decide what vehicle we're gonna buy. It's time to buy, we have budget, we need new trucks, we need new vans, we need new cars. Do we buy Ford? Do we buy Chevy? Do we buy Toyota? Do we buy hybrid? Do we buy gas? Do we buy EV? All of this is now possible because we're able to look at the data down to such a microscopic place, and maintenance drives this. What we hear all the time we talk with fleets is, we need to get more out of our vehicles. We're not gonna get budget back this year to buy more. We need to get 5 years out of them instead of 4 years. We need to get 8 years out of them instead of 7 years. But how do you truly do that? It comes back to the data. And whether you have a giant team of data analysts, a small team, it's likely not enough. And I doubt many people in this room have more budget to hire more analysts and more people to be able to do this type of thing. We don't see that all the time. We actually got challenged on this recently. So we were talking with a company very similar to this conversation, telling them what was possible. They said, well, we have a full data team, 14 people. Great, let's do a bake-off. Old-fashioned bake-off. We took the same data set, so this is what the end goal we want. We're gonna do the full analysis. This is what it wants to look like. We got a call from them 14 days later, and they said, this is too much work for our team. We can't do this anymore. They got to get back to their jobs. They've been on this full time for 2 weeks straight. We did that in 36 hours. Done, back and going, huge data set, thousands and thousands of vehicles, and provided them with that information to say, this is what's possible, essentially in the snap of a finger versus a full team constantly looking at it. Now that team can look at the data and actually help you make the decisions on what actually can be done, from changing the way we schedule, change the way that we maintain the vehicles, change the way that we do our preventative maintenance, making sure we're staying on top of certifications and compliance and all those types of things. And now they can help you make those decisions as opposed to people just crunching numbers and sitting in spreadsheets all day and building graphs. So this creates that increased efficiency. So really being able to do more with less, which then creates a cost savings because of all the different outputs that we're getting out of that. So things like enhanced safety, increased visibility. So, you know, being able to understand when a driver brings a truck in and it's got an engine light on, you already knew it had the engine light on. You've been alerted on that engine light. We can now make decisions off of what that engine light truly means. Is this a critical issue that we need to take care of? Or is this something that can happen on next Tuesday's PM or next week's PM? Do we need to tow the vehicle? Or can it just continue on? So being able to really understand all this and have that at your fingertips is key. So about this point is usually when I get people going, this sounds like a lot of work. You're creating more work. The other big piece of this is how much of the noise we can now take away. So if you think of the telematics set and all the data that you're getting from the vehicle, it's a ton. Being able to pull out what truly doesn't matter and only bringing forward what matters is super key. So with our models now, we start to understand criticality, and we'll dive into this a little bit deeper, but truly being able to understand what matters and what doesn't. So now being able to understand things like priority vehicles versus vehicles that maybe aren't a priority. So we're again back to the decision making. So we're going to focus on a couple of key areas within fleet management. This is what I've been talking about, which is predictive maintenance and data analysis. What we see typically is people have a lot of vehicles, a lot of data, they have a lot of work order information, a lot of invoices, whether it's digitized, on paper, or scanned and put into a system. And then things like diagnostic tools, repair guides, partnerships around diagnostics, things like that. And in some cases, this is all connected. In most cases, maybe one or two is connected, but really it's not bringing it all together. So what we try to do is bring in the AI layer in between there to become the hub for all of those pieces. So now being able to understand the full look at everything that's going on within the fleet, what can be done, what's been done in the past, also super key. So when you think about predictive maintenance and go back to the analysis of let me know when my truck's gonna break down a week ahead of time, that's great, but what happened last week with it? And what happened the week before, the month before, the year before? Because that all plays as part of that story as that vehicle ages. What we learned is a majority of fleets are over-maintaining their newer vehicles and under-maintaining their older vehicles. Because we're saying, all right, we're gonna see this van every 10,000 miles or every 90 days, and there's nothing conditional to it, it's just the way we do it. And when I ask people, why do you do it that way, it's how we've always done it. The real answer to that is because we don't have a better way to do it. And with AI, we now have a better way to do that. We can now make recommendations because we're automating so much and providing the insights to be able to continue that on. So being able to automate issue management. So this is super tough in an old school format, even with great technology, with connected vehicles and telematics, because you're only really truly getting a lot of the data when it's in the shop, plugged into a scan tool, and even at that point, we're just seeing that point in time. When you're plugging in an AI layer on top of all of these types of tools, we're now doing remote diagnostics 24/7, 365. Even when the vehicle's off, sitting in the parking lot over the weekend, we're still scanning the vehicle. We're still understanding battery levels. We're still understanding the electrical system. We're understanding what trips it's been on, what trips it's taken recently versus farther in the past to understand everything that's happened for every single mile. By being able to do this now, we can automate all the issue management. So now we can say, all right, not only do we know fault codes have been triggered, lights have been triggered, and we plug into the scan tool, and yep, we've got a code, there it is, great, we get a 4-digit, wording on what it is, technician's gonna go look it up, but the story ends there. With remote diagnostics, and what we're doing, is we now know when was the first time it was triggered, when was the last time it was triggered, how many times has it been triggered? We hear stories all the time, well, it triggered only one time in the system, driver brought our into the shop, well, they just hit a bump, something happened, triggered a code, no problem occurred. We can now filter all of that data. So we're scoring everything with a level of predictability. What's a critical issue versus a major issue versus a minor issue? Typically, there's different best practices around it, but our fleets look at it as if it's critical, it's probably days. If it's major, it's probably weeks. If it's minor, it could be months or never. It might not be an issue that we want to truly take a look at. But it gives you the full picture, gives you the full story. So now we know what's a high priority vehicle. So when I talked to people and just had a conversation out on the floor earlier, we were talking about all this predictive stuff, and I said, that all sounds great, but I've got 100 vehicles that are overdue for PM. And my question was, which one are you gonna do first? Nobody knows. We're just gonna say, well, that one's the most overdue, or this is the truck we use the most. Well, now we can take a look, because we're looking at all the story, all the data, we can now say, yeah, that one's most overdue, but it has no critical issues, it has no major issues. Really all it's due for is an oil change and an inspection. You've got another vehicle that's likely gonna break down next week. So now let's flip the schedule. Now we know where our true priority is. We now can understand that because of the age of the vehicle or the terrain it's driving on or the way it's being used, that all vehicles aren't the same. And we could take this all the way down to an individual asset level. So within the systems, you could say, all right, this one we're gonna do in exactly this many miles versus this truck we're gonna do this much time, this one we're gonna do exactly with engine hours. That's a pretty extreme example, but if you've got 1,000 trucks or 500 trucks or however many within your fleet, you can say, all right, this group of vehicles we're gonna look at every 3 months versus this we're gonna look at every 9 months or every 50,000 miles or 20,000 miles or whatever the numbers may be, to be able to now create some conditional maintenance. But then also, because we're checking constantly, the AI can now let you know, we need to change schedule. We need to push off of this because we've got other issues. And now we wanna be alerted to that. So now we can set things like, I want a daily email of what's changed today versus yesterday. Do I have new critical vehicles that aren't scheduled for a PM, they're not overdue, it's weeks or weeks away from the next time we're gonna see it, but it could likely break down in the next 9 days. Now that can come to the top of your priority list. Now we can take a look at the schedule and we can say, okay, we need to bring this in. It also creates a situation to do more with less. And what I mean by that is keeping cars, trucks, vans on the road as much as possible. Because what we hear from a majority of our customers when they come on board is, we just had this truck in for a PM, back in the shop 5 days later. And then it came back in 5 more days later. And then it came back in 7 more days later. And our goal is to reduce that as much as possible. And that's done in 2 ways. So one is bundling services in together. So as we're talking about scheduling and flipping schedules, and we've got a truck coming in next week, but it might break down now, let's bring it in. Let's do the PM, let's fix the critical issues and get it back on the road. In situations where vehicles are perfectly fine, maybe it's overdue for its PM, but it's a newer vehicle, it has no issues, we have no historical issues, let's let that run, let's push that out a little bit. That's an over-maintained situation. And one of the key things we look at is how often are vehicles coming back in? And this opens up another world of decision making. So being able to now track how often are certain brands, makes, models coming in back after a PM. Maybe it's just our Fords aren't that good. They're just really not. They just always come back in. But now we can understand ahead of time. I didn't say garbage trucks. I know that would make everything. But being able to now understand what can we do, bring it in to get the optimal schedule. So things like inspections that are due, DOT inspections, the scheduled PM, and then what else are we gonna fix within that? And now being able to understand the full picture of the vehicle, to be able to maintain the vehicles better, better, better. And then give checks and balances to make sure we actually are doing it better, be able to give a scorecard. The other piece too that trickles down to is the shops itself. I've got Mike doing PMs and I got Joe doing PMs, and Mike's vehicles just keep coming back. We can now track that and understand, maybe Mike needs to get a little more training. Maybe that's not his best place to do things. Maybe we need to understand a little bit more how we're doing it at one shop location versus another, not to bash on Mike. But being able to now understand, we have a different way of doing things. We're starting to do things a little bit smarter. We have the data to back it up. So it's not just like, Mike, you're not doing a good job. We actually know. By the way, Mike, your vehicles come back every month after a PM. What's your inspection process look like? Are you checking the boxes, or are you actually doing inspections? The other thing this opens up for us too is making sure that Mike's actually working that day. So we've got a vehicle scheduled for a PM. We've got a critical issue that could cause failure on the vehicle. It's scheduled for Friday. Mike's on vacation Friday. Why would we bring the vehicle in, let it sit, if we can't get another technician? Maybe we need to send that out to a shop. Or maybe we know we have an issue with the fuel pump. Do we have the parts for that? So now being able to now schedule our day and plan our day, and putting this in really easy formats for both a fleet manager or a data analyst who can look at the dashboards, get the alerts, but also down to the technician level to give them the health report. So a true scorecard that provides full history of the vehicle to be able to say, okay, here's the issues that we're seeing with the vehicle. Here's the level of criticality. Are they major issues? Are they minor issues? They're algorithmic issues. So because we're scoring everything together, we also know that there's clusters of issues that cause problems. This happens a lot within diesel exhaust especially, where something that's a minor issue is a minor issue. But if you've got 3 minor issues together, that creates a critical issue. So now we can say, okay, Mike, you've got these 3 minor issues. Algorithmically together, when those are clustered together, we know the vehicle is going to break down in a week. This vehicle is going to derate, we're going to get a tow truck. We don't want to do that. Let's now bump that up to a critical issue. And now we can let the fleet manager know, how do you want to be notified for that? For those specific issues of clusters, do we want daily email? Do we want to email the second we get it? Do you want a text message that goes out directly to the right person to get that dispatch to be brought in? So now we can make decisions like, do we have to tow it? Do we need to get it off the road? Is it safe to drive? Do we bring it in next week when it's scheduled? Do we need to bring it in right now? And the AI is looking at all of these models and running it through machine learning over millions and millions of miles of similar vehicles. So now we know the true level of criticality other than just a one word. It's, nope, this vehicle is going to break down in 6 days. We need to bring it in, PM scheduled for 9 days. Again, we're adjusting schedule. And then now being able to look at, again, the full picture, what else are we going to do within it? So So having a true priority list with your vehicles. So this works great in real time. It also works when you're behind, because now we can take a look at the list and say, let's